Hey everybody, welcome back to another math video. Today we're going to be doing transformations with quadratic functions. So transformations with quadratic functions. Now, you probably learned that quadratic functions have a highest exponent of 2. So we're going to be working with f of x is equal to x squared. And when you graph this function, you get a familiar parabolic shape, which is basically a U shape. It's going to start with a vertex of 0, 0, and it's going to have that x squared shape. Now, with this function, you can do a lot of stuff with it. You can do a lot of transformations. You can move it up, you can move it down, you can move it to the left, you can move it to the right, and you can also enlarge it and shrink it, and you can reflect it over the x-axis and the y-axis. So those are the transformations that we're going to be doing today. Now, the first thing that I want to do is I want to move this function up by 3. So what I'm going to do is I'm going to get a completely different function, g of x, and I'm going to keep it as x squared, but I'm going to add 3. I'm going to add 3 to it. And what that does is it takes the purple function and it moves it up 3. So now the new vertex is going to be 0, 3. So that's how you move a function up. You just add a number to it. And same way if you want to move it down. Let's say I wanted to move it down 3. Then what I would do is instead of adding 3, I would subtract 3. So that way the function moves down by 3. So that's how you move a function up. You add a number to it. And if you want to move a function down, you subtract a number from it. So that's moving up and down. Okay? So the next thing that I want to do is I want to learn how to move a function left and I want to move a function right. And the way I do that is I actually add parentheses to it. So I'm going to put a parentheses around the x. So that way I can put numbers inside the parentheses. So now if I add a number on the inside, like let's say I add 1, the function moves to the left, right? So the function has moved to the left by 1. And that's because I added 1 on the inside right here. Now, if I wanted to move to the right instead, I would, instead of adding, I would subtract on the inside. And that moves the function to the right. So it's really interesting to learn how to move left and right. And, I run into some students who think that if you add on the inside, you actually move to the right. But that is not the case because, as you can see, if you add 1 on the inside, you move to the left. And if you subtract 1 on the inside, you move to the right. So that's the difference between left and right. Left is adding, and going to the right means you are subtracting. Okay? And you can even combine different transformations. So if I was to subtract 1 on the inside, of course, I would move to the right, just like I'm doing right here. But I could also add 1 on the outside, and I would move up. So you can combine multiple transformations to get a new function. And this function is moving to the right 1 and moving up 1 because I'm subtracting 1 on the inside and I'm adding 1 on the outside. Okay, so that is up, down, left, right. I am going to get rid of all these transformations and I'm going to go back to the original x squared, removing the parentheses too. So now I have 2 functions and they're basically the same thing because they're both f of x equals x squared and g of x equals x squared. And what I want to do now is I want to learn how to stretch a function. So I can stretch a function if I multiply it by a number that's bigger than 1. So let's say I multiply x squared by 2. I put a 2 on the outside. And what that does is that takes the purple function and it vertically stretches it by 2. And as you can see, the black function is a more narrow function than the purple function. And that's because I multiplied it by 2. Now, if you multiply it by an even bigger number, like let's say 10, you're going to get a very narrow function, right? This black function is much more narrow than the purple function that I had. So that's if you multiply by a number bigger than 1. But let's say you multiply by a number that is less than 1. Like let's say you multiply by 1/2. Let's do 1/2. Now the function gets wider. The purple function, which is the original one that we started off with, it has been transformed into this black function right here, which is much more wider than what we started off with. And as the number gets smaller and smaller, like let's say we multiply by 1/5 instead, we get an even wider function. And if we multiply by 1/10, we get an even wider function than that. So the smaller the number is, the more wider the function is. So this would be called a vertical shrink or a horizontal stretch. So that is vertical stretches and vertical shrinks. And you can also do reflections. So if I put a negative on the outside like this, I get negative x squared, which is basically taking the purple function and then flipping it over the x-axis. So this is called a reflection over the x-axis. So if you put a negative on the outside, the function is going to flip over the x-axis. So that is a reflection. And if you put the negative on the inside of the parentheses, like I'll show you here, if you put the negative on the inside of the parentheses, what happens there is you flip the function over the y-axis. So now if you take the purple function and you flip it over the y-axis, you get the black function, which are actually the same two functions, because if you take that x squared shape and you flip it over the y-axis, you're not really changing anything about the graph of the function. So if the negative is on the inside, you flip over the y-axis. But if the negative was on the outside, like this, you'd be flipping over the x-axis. So that is transformations with quadratic functions. And once again, you can move up, down, left, right, up, down, left, right. You can also do reflections, and you can also do vertical stretches, and you can also do horizontal stretches. So that is transformations, and I hope that helps.